Okay. Loud and clearly. So can you hear me now? It's okay for you about the voice?
Yes, it's good.
Yes, ma'am. Yes, ma'am.
Okay, maybe
Yes, po, ma'am.
maybe louder. More. Okay. Yes. So maybe let's begin about today's training. It's okay for you?
Yes, ma'am.
Okay.
Yes po, yes.
First, welcome to Ruijie training. This is my first time about the global public training. And today our topic is about Ruijie switch and AP. Of course, some key technology, not about everything, okay? So before this class, let's have a brief introduction about myself and about this course. And my name is Emily, and here is my email address, and this is my picture. In China, everyone take a picture, we use Photoshop to do a little different, okay? And I am the trainer of the Ruijie Regional Technology Team, and over 6 years, focus on the training on the security, like the firewall and the routing and switching and wireless, something like this. And about this course, we have 3 hours. So it's a little long online because maybe everyone will think the time is too long, so we'll be tired. And we have 3 topics. The first one is about a Ruijie switch. We will talk something about layer 2 technology, like VLAN, like FTP, like link aggregation, something like this. And the second part is about a Ruijie AP. And this is very useful in our network, right? Because now everyone have the phone and we want the phone to reach the internet. So the main part, the main devices is the AP. And the third part, I will explain something about the Ruijie service and some support. So besides the training, you also have other tools to get some support about the technology. Maybe you get some trouble and you want to do the troubleshooting. We have so many tools we can use in the Ruijie. So this is about the course. And in my training, I have one requirement. Pay attention. If you have any problem, please directly ask me. Or maybe you can directly to open your voice, or maybe you can write down on the chat window. After one topic of the technology, I will see the question and the answer with you. Or maybe after the training, I also will explain the question for you. So if you have any problem, please directly talk to me. It's very important to me, and I think it's also very important to you. So this is about my requirement. It's clear for you? Yes?
Yes.
Okay.
Yes, ma'am.
Don't be shy, okay?
Sure.
So let's begin our today's training information. Because when I received I set the invitation on the Google, and I also get some suggestions and get some questions. If I don't have the basic technology, can I join the training or not? Actually, I have 3 questions for you. If you can give me the answer, I think it's very easy to enjoy the training. The first one, in our communication network, we have 2 very important reference modes. One is OSI and another one is TCP/IP, right? So how many layers of the OSI reference mode? Do you know how many layers?
7.
Yes, 7. I see so many. The correct answer. Yes, it's very good. 5. 5 is TCP/IP, right? So this is the first question. The second one, when we transfer the packets in our network, maybe the router, maybe the switch, maybe our laptop, we will use 2 address. One is IP address, right? So how many bits of the IP address? Do you know the answer?
16. 16. 32.
32, right? Yes, 32 of IPv4. I guess maybe someone know. Oh, who writes the answer? So many answers. Yes, this is 32. And besides the IP address, right? We also have another address. This is MAC address, right? So how many bits of MAC address? Do you know the answer? 48? Yeah, 48, right? Yeah, so about these three questions, if you know the answer, I think following the technology is very easy for you to understand, because I will explain the packets, how to do the encapsulation, and when the switch receives the packets, how to forward the packets, and all the packets we have to finish the encapsulation. We will add the information of layer 5, layer 4, layer 3, layer 2, and finally to be the binary and use a cable to transfer the packets out. So within the encapsulation, the very important parameter of layer 3 is the IP address. Of the layer 2 is the MAC address. So when the switch receives the packets, if the switch is layer 2, we will forward the traffic according to the MAC address information. So later, let's see the first topic. For example, very simple scenario. For example, now my PC1, and my colleague Jason, he also have a PC2. We belong to the same department, is the IT department. Now we want to use the phone to transfer the file with the two computers. And we already connect with the cable and give the IP address and also give the MAC address, right? So let's see the process. If I want to say, for example, I want to use the FTP to send the packets to PC2, before we send the packets, usually we will use a tool. This tool is ping, right? I think everyone uses a tool, right? To ping the destination is successfully or not. So let's see the process. How to finish the ping. About the PC1, we will use this PC and use the command on the DOS ping, and then to give the destination IP address 192.168.1.2, right? And then the PC1, the laptop, will do the encapsulation to add the layer 5 information, layer 4, layer 3, and layer 2. We only focus on the layer 3 and layer 2. Let's see the process. PC1 will do the encapsulation, right? We will add the source IP address and the destination IP address. It's very easy to understand, right? Because I've used the tool on my PC1, so the source IP address is 1.1. The destination IP address is PC2, so the address is 1.2. And I have a question about the layer 2 information. Source MAC address is MAC address A, right? Because I use a PC1 and the network card already has the MAC address. But the question is, what's the destination MAC address? Who can show me the answer? What's the destination MAC address? Yes, someone says MAC address B, right? Should be MAC address B. But PC1 don't know. Why PC1 gets the destination IP address? Because on PC1, we add the command, is this one, ping 192.168.1.1. So that's why the PC1 can directly use this IP address and then fill in the destination IP address. But how to get the destination MAC address? We don't know, right? Because we don't use the command to tell PC1. So how to get this information? Very important protocol is ARP. Do you know this protocol? ARP is used to translate the IP address and the MAC address. And by default, ARP is a broadcast packet. That means PC1 will ask everyone who knows the MAC address of PC2. So PC2 receive it, will give a reply. But pay attention, at the beginning, the ARP request is a broadcast packet, right? Of course, if you want to know the detail of ARP, you also can learn some information about the RCNA technology, right? Before we join the training, I already show you how to register the e-learning account, and you can know something about the ARP on the RCNA certification course. And use this protocol, finally, we know the MAC address is PC2. Yes, is this related to ARP table? Yeah, at the beginning, the ARP table also is empty. Yes, so we will broadcast and then to get the MAC address information. After we know the MAC address is MAC address B, then the PC1 will encapsulation again, and the source IP address, the destination IP address, the source MAC address is A, and according to ARP, we know the MAC address is B. So finally, after we encapsulation successfully, then PC1 will send out the packets to PC2. And this packet is used to test the connection between PC1 and PC2. Actually, in our network, it's very easy to understand. If you want to send out a firewall, or maybe you want to send out some message, or maybe to test the connection, that means I will give you a packet and you can receive and give me a reply. That means the connection is okay. Yes. Can't record for the meet and said please ask the host. I'm the host. I already recorded the information and later I will show you about this one. Okay. So this is the process of the very easiest scenario of two PC and directly to connect with each other, right? The network is very simple. It's very easy to understand, right? So later in our real network, maybe the topology is a little complex, something like this one. Also, my PC want to take a communication with my colleague Jason, his computer PC too. We're still within the same IT department, and we want to transfer a file using the computer. But now the different one is my computer on the 3rd floor, but the Jason is on the 5th floor. So what's the problem about the before technology, before the topology? As we know, we have the limitation of the cable, right? The default, the maximal distance is 100 meters. So if we located in different floor, maybe the cable sentence is not enough. Of course, if you use one very long cable to connect with each other in different floor, it's not beautiful. So how to solve this problem? Who knows the scenario? Yeah, someone say we can use a switch or hub. It's correct. For example, now we will use a switch. And to connect with two PC, of course, if maybe one switch is not enough, we will use multiple switch, right? And to make the distance longer and they can connect with each other. So now we have to know how to work about the switch, because if we directly connect with each other, we can encapsulate the packets, then to use a cable to directly for the traffic. But now if we add the switch, how to work about the switch? Let's see the process. It's very important about the switch. Before we talk about the principle, let's see how many types of the Ethernet frame. Ethernet frame means when we finish the encapsulation and add the layer 3, layer 2 information, finally the packet we call is frame. If we use the Ethernet protocol, that means this is the Ethernet frame. By default, the switch use the protocol is Ethernet. So what types of the frame? Actually, the first one also we will see is the unicast packets. What means the unicast packets? For example, if I now send the packets and I directly send to the destination, this message I will send to Jason. So this packet we call is unicast. Yes, one-to-one communication. Like this topology, if the source PC sends the packets out and the destination MAC address is unique. For example, now the MAC address is the middle computer, right? So this packet we call is unicast packet. And this packet finally will be sent to the destination, and only the destination, the receiver will receive the packet and give a reply. And all the other packets will, all the other terminal will directly to discuss the packet. Yes, so this is unicast. And the second one is the broadcast packet. The broadcast packet special one is the destination MAC address or one, so should be OF when if you use the Wireshark tool to get the packets, you can see the destination MAC address. And all nodes in the broadcast domain will receive the packets. So if like this one, now the terminal send out the packets, the destination OF, and everyone will receive the packets and will see what's the information on the packets and finally to decide to give a reply or not. For example, in the first scenario, the PC1, my computer will send out the ARP packets, right? The first ARP request is a broadcast packet. So everyone will receive this one and to decapsulate packets and to see this message is sent to me or not. If no, I will discard. If yes, I will to give a reply. So the terminal will take the resources to deal with the packets. So two types. Actually, in our network, we have the third one we call is multicast, but this is not the key point in today's training. And then let's see why we explain two types. Because when the switch receives different type of frame, we will have a different action. And about the switch, we have two actions. That means two functions or two ways we have to finish. The first one is learning. Because switch connect with multiple terminals. When I receive the packets, I have to forward the packets, right? So maybe about switch, we have multiple ports. Maybe have 10 ports. I receive from port 1, and then this packet should be sent out all the rest, all the interface, or maybe the port 4, or maybe port 7, something like this. So who will make the decision? It's because it depends on your MAC address table. So this one is very important about the switch. So about switch, at the beginning, I have to make my MAC address table much entries as possible. So I can forward the traffic according to this information. If the entries is empty, I will do the flood. Flood means everyone will receive this packet. So if this action will waste the resources. So this is the first process the switch have to know, learn the MAC address and add this information in the MAC address table. The second function of the switch, I have to finish the forwarding because I am the network device. When I receive the packets, my main work is to forwarding the packets. And how to forward the packets according to the MAC address table. And when we check with the MAC address table, we have 3 actions. The first action is forward. Forward means like this one. If we have 5 ports about the switch, I receive the information from the first port, and then I will check with my MAC address table, right? And the MAC address table will show us you have to send out the packets from port 4. So finally, this packet will be sent out. This is the action of forward. The second function is flood. Flood means I also receive from port 1. But finally, which port will be sent out the packets? All the rest of the ports. 2, 3, 4, 5. 4 interfaces. So this is flood. Which packets we will take the action of flood? The first one is broadcast. The second one is unknown unicast. What means unknown unicast? Because about the forwarding, we see the switch will check the MAC address table and finally to decide, right? According to the destination MAC address. If I cannot find this information, this unicast packet we call is unknown. About this packet, we will flood. And the third one is discard. Discard means I also receive the packet from the first interface, but finally I will not forward the packet. So this action we call is discard. So about the switch, totally we have 3 actions. And later, let's see the first process, how to learning the MAC address, how to make the MAC address table as much as possible. Let's see the process. It's very important. First, if the switch is at the first time to start, there is no entries in the MAC address table, right? For example, now let's show you a topology. There is a switch and connect with 3 terminals. And the first time the MAC address table is empty. There are no any information. On the table, we have 2 parameters. First one is the MAC address. The second one is the interface. MAC address, we will add from the source MAC address. And the interface is the receiving port. So these 2 parameters is very important. So this is the first time there is no entries. The second time, the PC1 will send out the packets. Maybe it's broadcast packets, maybe it's unicast packets, anything, some like the topology now, PC1 send out the broadcast packets. And then when switch receives the packets, I will add the information into the MAC address table at first. Pay attention which parameters will be added into the table. The first one, we will add the source MAC address information. Pay attention about this. So, and the second one, we will do the association with the receiving port. So this is a principle, how to learning the MAC address. So after we receive the packets from PC1, I will update my MAC address table, right? Add this information. The MAC address is the PC1 IP address, and the interface is the interface 1 to add this information. So this is the first action we have to learn. And then we have to forward the packets. About the switch, not only about to learn to make the entries more and more, the main function is to forward the packets. So later, the switch will forward the packets according to the destination MAC address information. But this packet is very special because the destination MAC address OS. So this is a broadcast packet. That means I will forward the packets from other ports, everything. In this topology, we only have 3 ports, right? So this packet will be sent out from switch port 2 and port 3. But pay attention, except the received frame. The packet will not send to port 1 again, otherwise maybe there is a loop. So this is the first one. I learn 1 entries and then to flood the packets. So this is the first step. Then the second one, when PC2 and PC3 receive the broadcast packets, right? Broadcast means everyone receive, everyone have to deal with the packets. That means maybe PC2 and PC3 will give a reply. Of course, decides on your real network. Not every broadcaster will give a reply. Depends on the real network. For example, if the PC1 send out the ARP broadcast packets, maybe finally only PC2 will give a reply. But some other broadcaster, maybe everyone will give a reply. In this topology, maybe 2 and 3 will respond to the frame, right? When we give a reply to switch, and this reply information also is a complication of encapsulation. So these packets will carry the source MAC address and the destination MAC address, something like this. And the switch receives the packets. I will add the packet information of the source MAC address, also the receiving port. So the switch will add this information into the MAC address table again. In this scenario, we will find the switch now have 3 entries, right? From PC1, PC2, and now we have 3 interfaces. And later, if now we have the unicast packet, for example, PC1 sends the unicast frame to PC2, And the source MAC address is PC1. The destination MAC address actually is PC2 IP address. When switch receives this information, I will also take the destination MAC address to match the MAC address table. Finally, we will find the MAC address is connected with the port 2. So this packet finally will be sent out to port 2 according to the MAC address table. I can see. Yes. I can meet the MAC address, and this is the interface, and then we will finally to forward the traffic, right? The packets finally will forward to port 2 to PC2, and the PC3 will not receive this information. So this is the function of forwarding. Of course, in this scenario, if PC1 send out the packets to PC3, and PC3 only will receive the packets. So this is a process. And about this process, pay attention. It's very easy to understand. And the switch, we don't need to give any configuration. This is a basic function of the switch. That means the switch will finish the learning automatically and forward the traffic according to the MAC address table. So you only have to power on the switch, and then the switch will finish the function automatically. But pay attention in your network. If your network is very big, maybe the entries of the switch is not enough. So this is the first problem you have to know. If the destination MAC address not located on the MAC address table, the switch still can forward the traffic to the destination, but the action is flat. This one we call is unknown unicast. So this action finally will send the packets to the destination, but also waste the resources. So this is the main problem we have to know. This is the action of the forwarding. And about the flood, this is the scenario as I say, if the switch receives a broadcast packets, multicast packets, or unknown unicast frame, and the switch will do the flood. Flood means except the receiving interface, I will forward the traffic to the rest of the interface. So this one is very waste the resources. But pay attention about these three frames, broadcast and multicast, we cannot control because the switch will forward the packets as much interface as possible. But about the unknown unicast, we have to do some control. For example, if the entity of the switch is not enough, maybe you can increase or change a higher performance of the switch to make the entries as possible, as much as possible. Or maybe the entries you will see so many MAC address on your table. Maybe there are some problems like a loop, and we will update the table as possible in our network. So about the switch, we cannot forward the normal packets. So this is the flooding action of the switch. About the broadcast, multicast, and unknown unicast packets, we will do the flood. Like this action, I will receive from port 1 about the broadcast packets and match to the MAC address table. We will find two interfaces, right? Then we will send the packets. Send out from all other ports, but pay attention, except the receive port, because this is used to avoid the loop. So this is a flood. All the computer will receive this information.